Hello, my name is Klim Zaporozhets and I will present our work titled Towards Consistent Document Level Entity Linking, Joint Models for Entity Linking and Coreference Resolution. Consider this example where named entity mentions have to be disambiguated. For the sake of simplicity, we don't highlight all the possible named mentions in the current text, but only focus on mentions representing two entities. Lionel Messi, with mentions like Lionel Messi, Messi and the Messia, and Argentina national football team with mentions like Argentina, Gauchos, Albiceleste. In our work, instead of disambiguating each of the mentions individually, we assign the disambiguation link directly on coreference cluster level. This is illustrated in this slide, where each of the coreference clusters groups mentions referring to the same concept. In other words, all the coreferent mentions Lionel, Messi, the Messia, and Messi of the first cluster refer to Wikipedia entity Lionel Messi. And the mentions of the second cluster, Gauchos, Albiceleste, and Argentina, refer to the entity Argentina national football team. This allows to make more consistent predictions across all dimensions referring to the same concept, as well as to reuse candidate entities of each of the mentions. This latter point is illustrated in the current slide. A more traditional mention-centric approach would have troubles when disambiguating mentions that do not have correct candidate entity in the candidate list. This is especially true for unpopular mentions used to refer to a particular concept, such as the mentions the Messia, over here, referring to Lionel Messi, and Gauchos, referring to Argentina national football team. None of the candidates of these two mentions contain the correct entity. We tackled this problem by proposing to join entity linking and coreference resolution in a single structured prediction task. Our first approach consists in linking each of the entity mentions, such as the Messia, over here, to either previously mentioned span in text, such as Lionel Messi over here, or to one of the candidate entities, such as Messia handle or the Messia wrestler over here. A possibly correct prediction path in this example would begin in the Messia, which is the last mention in text referring to Lionel Messi, then link to mention Lionel Messi, and then link to the entity Lionel Messi over here. More formally, the modeled probability of text span of candidate entity Y, being the antecedent of span S sub I, can be represented as a softmax over all possible antecedent spans and entity candidates of span Si. While straightforward, this approach cannot solve the cases where the first coreferenced mention does not include the correct entity in its candidate list. Consider this example where the order of mentions the Messia and Lionel Messi has been switched in text. Now, the link cannot be correctly predicted on the cluster level, since the earlier mention in text, such as the Messia, cannot be linked to spans occurring later in text containing correct candidates in the candidate list, such as Lionel Messi in this case. To solve entity linking in this more general case, even when the first mention does not have the correct entity, we propose bidirectional connections between mentions. Thus, leading to maximum spanning tree problem in our global approach. The spanning tree is rooted in the root node, and the mentions can be connected to other mentions, the entities, or the root itself. One of the possible correct spanning trees would be to connect the mention the Messia to Lionel Messi, then to the candidate Lionel Messi, and then to the root. The rest of the entities, Messia handle and Messia wrestle, are linked directly to the root without any mention span pointing to them, indicating that those entities are not associated to any of the mentions in text. A naive approach to minimize a low likelihood of such a model requires to perform a sum over all possible spanning trees, which is unfeasible since this number is exponentially large. To circumvent this problem, we propose using Kirchhoff's matrix tree theorem and replace the sum over all spanning trees by the determinants of Laplacian matrices in the graph. Please refer to the appendix of our paper for a step-by-step illustrative example of how the determinants are calculated. Our general results shows an increase in performance of up to 5 percentage F1 points on entity linking task compared to the standalone baseline. We also observe that on average the performance of global model is superior to the local one. Our joint models tend to also produce more coherent predictions on clusters containing multiple mentions, represented by letter M in this table. On such cases, we notice an increase of performance above 10 percentage F1 points compared to the baseline, with our global model producing the best results. Finally, we report accuracy of entity linking on mentions without correct entity in the candidate lists. As expected, the standalone baseline model cannot link such mentions, as it is limited to the local candidate list. In contrast, both our joint approaches can solve some of these cases by using the correct candidates from other mentions in the cluster, with a superior performance of our global model compared to the local one. Please contact us for any further comments or questions on our work. Thanks for your attention.